This is the lecture for topic 8.4 and 8.5 to solve an equation containing fractions and also literal equations. This goes with your assignment number 3. So if you notice that there's fractions, especially more than one fraction present in an equation, it's a lot easier if you'll multiply the entire fraction, both sides, by a common, what the least common denominator would be. We're not changing it to have the same denominator. What we want to do is remove the denominators by multiplying. Like if you look at example 17, we have a 3 and a 4 in the denominator. Both of those numbers can go into 12. And so what I want to think is, I just want to take this whole thing times 12. And really, you're saying I'm taking 12 times, and then you have this expression 20 minus 2x over 3. And then we have our equal sign, and we have that 4x plus 7 over 4, and you're multiplying it also times 12. I just like to put it on the outside, just makes it easy to see. And so what happens when you do that is you're going to be cross-reducing your denominators out, okay? So what's in the denominator should go into what you said you're multiplying the entire fraction by. So like 3 goes into 3 one time, so I can cross it out and put a 1, that got rid of it. And that 3 goes into 12 4 times, cross it out and put a 4. So you're going to be taking 4 times this. Since there's more than one thing, I want to think of it like an expression, so put it in a parentheses. So we have 4 times 20 minus 2x. So by multiplying it times 12, we got to get rid of that 3 that was in the denominator. We'll be doing the same thing over here. We have to multiply the other side also by 12. So you multiply everything in it by the same number, which was 12. 4 goes into 4 one time, and 4 goes into 12 3 times. So again, this number should be able to divide up into that number evenly. And you cross it out and put the quotient above it. 4 went into 12 3 times, so we cross it out and put the 3 above. So again, since that's more than one term, we put that in a parentheses. So it's like we're taking 3 times all of that. So I like to put it in the front. You could still let it hang out there on the back side of the parentheses if you want. Now it's much easier to work with like this. We can just simply distribute and solve. We don't have to work with a fraction throughout the whole problem if you remove them in the first step by multiplying it by that 12. So 4 times 20 is 80, and 4 times a negative 2x is a negative 8x. 3 times 4x is 12x, and 3 times 7 is a positive 21. So we're going to be moving terms side to side. There's not any like terms on the left side, so there's nothing to clean up. There's nothing to clean up on the right side. So I like to take and put my variables on the left when I can. So since this is a 12x, we would subtract 12x. Remember, you're moving the entire term to the other side. We're not trying to get the 12 away from the x. I'm trying to take this whole thing and move it over. So that's why I subtract it. So I'm going to bring down my 80 and a negative 8 and a negative 12, make a negative 20x equals, that's a positive 21. So then I would move my 80 over to the other side because I have my variables already over here. So since that's a positive 80, I would subtract 80. So 80 minus 80 would zero that out. So I would bring down my negative 20x equals, and a 21 minus 80 is a negative 59. Now our final step, negative 20x. To get the negative 20 away from the x, you divide by that negative 20. So negative 20 divided by negative 20 makes that a 1x. I'm going to have to put it over here because I ran out of room. And 20 can't divide up into 59. You do not want to turn that into decimal. You need to leave it as a fraction. But the one thing we do want to do is clean up the negative. So since there's 2 negatives, it's really a positive 59 over 20. If you could reduce in that 59 and 20 could be divided by a common number, you would do that. Otherwise, just leave it as an improper fraction. Okay, looking at example 18. Again, we have more than one fraction happening. So what we want to do is get rid of the fractions all in the first step. So we have a 12, a 6, and a 4. And what I noticed is 4 can go into 12 and so can 6. So again, we're just going to multiply this entire thing by 12. So it takes a little bit setting up, but I'm going to write and show that I'm multiplying 12 times everything, every fraction or every term in that problem. So I have 2x minus 5 over 4. And then I'll just put the minus sign there and write 12 times 3 minus x over 6 equals 12 times 11 over 12. So notice I'm just multiplying all things times 12. I just didn't write it in red this time. And so if that happens, you'll see how we can cross reduce this out and get rid of the denominators in this first step. So 4 goes into 4 one time and 4 goes into 12 3 times. So what we have left here is really like saying 3 times 2x minus 5. And then over here, I brought down my minus sign. 6 goes into 6 one time and 6 goes into 12 two times. So we cross it out and put a 2. So we're taking 2 times the 3 minus x. And then here you can see 12 goes into 12 one time. So this would really just kind of be like 1 times 11. So really we just write 11. And then from there, you can just distribute and finish solving. So let's go ahead and do that. Remember, at any time, if you feel like I'm going fast, just pause, rewind it a little bit, and go back. 3 times 2x is 6x, and 3 times a negative 5 is a negative 15. Oh, I don't know why I put equals. I shouldn't have, sorry. So I'm taking this negative 2, think of that negative goes with that 2, times 3 is a negative 6, and a negative 2 times a negative x, pick those negative signs up, is a positive 2x. So on this problem, if you notice, I like to talk about cleaning up one side of the equal sign, which we can. We have x terms that are alike, so we're just combining them. 6x and 2x make 8x. And here, negative 15 and a negative 6 make a negative 21. So again, it's kind of like sorting our laundry. Remember, that's kind of my memory device, or the thing I kind of refer back to. We're doing So we're trying to finish solving for x here. So we're going to add 21 over. So 8x equals 32. So we're going to divide by 8. So x equals 4. Okay, so let's go look at number 19. Number 19 has fractions in the problem. And so this one's a little bit different than the two we've seen so far. You have fractions in front of parentheses. So when we get rid of these denominators, really we're just doing it to the fraction part in front of the parentheses. There wasn't any parentheses in the ones above, so I just want to kind of point that out, the difference. So 3 and 2 can both go into 6. So we're going to multiply times 6, but really the only thing that's being multiplied times 6 is that fraction in front. The parentheses is staying the same. And so I'm going to write 6 times 1/2, 1 minus z. Okay, so now you can see 3 goes into 3 one time. So we can cross reduce that denominator out, and 3 goes into 6 two times. So 2 times a negative 2 is a negative 4. And 2 goes into 2 one time, and 2 goes into 6 three times. So 3 times 1 is just 3. So notice if there's parentheses in the problem, if you're multiplying times a LCD, a least common denominator, you're only multiplying on what's on the outside of the parentheses, because then that's what's getting distributed inside anyways. So now we can distribute. Negative 4 times 2x is a negative 8. Actually, that's a z, 8z. Minus, or it'd be negative 4 times a positive 3 is a negative 12. 3 times 1 is 3, and 3 times a negative z is a negative 3z. So now we do have z's on both sides and constants. So I'm going to take this entire term, and I like to move it to the left when I can. Since it's a -3, I want to add 3z. So what I have is a -5z. I get to bring down -12 equals 3. And then we're going to move 12 over. It's a -12, so I'm going to add 12. So I have a -5z equals 15. So then our last step, hopefully you've been getting a lot of practice from the assignment before, that this part of the process is easy for you by now. So z equals a -3. Hopefully what you're learning in this assignment is mostly how to get rid of the denominators in the first step, and then everything else is just like what you were working on in assignment 2. One more problem, this one does not have parentheses in it. So I have a 3 and a 4 in the denominator, so we're going to use 12 again. Both of those numbers can go into 12. So we're going to have to multiply each and every term by 12. So 12 times 2 over 3x plus 12 times 5. So each term, you can kind of think of it like you're distributing it in a sense. Goes to each and everything. Then we have our equal sign. This is a 5. It wasn't a very pretty 5. 12 times 2x and 12 times, I'm about to run out of room, 5 over 4x. Okay, so we can cross reduce. 3 goes into 3 one time, and 3 goes into 12 4 times. So we have 4 times 2x is 8x. And then if you take 12 times 5, you get 60. So we have that's what this is, positive 60 equals 12 times 2x, which is 24x. And over here, we're cross reducing the 4 and the 12. You know, I know it's kind of sloppy, I'm sorry, but this is reading 12 times that 5 over 4x. So 4 goes into 4 one time, and 4 goes into 12 3 times. And then we have 3 times 5x is a positive 15x. So on this one, notice you have like terms over here. We want to combine those before we do anything. Clean that up. It wasn't a constant this time. It was just maybe a variable. So we're just saying 24 and 15. You're just combining them, adding them to make a positive 39x. So on this one, I personally would not move this to the left because there's nothing else over here with it, right? So I might have to move a variable from the left to the right sometimes. Doesn't always happen, but it can. Since it's a positive 8x, I would subtract 8x to move it over. So I have 60 equals 31x. Now I can divide because I want to get x by itself. So divide by 31. So 60 over 31 equals x. Again, you can't reduce that. Do not turn it into decimal. Leave it as an improper fraction. So it's just really important that you understand you always have an equal sign between your two sides. Hopefully you've really mastered that since assignment 2. You won't always be moving a term from the right to the left that has the variable. Not always. In this case, there wasn't a constant. So you have to have something on both sides. So that's why we moved it to the right-hand side by instead. Kind of went in a different order. If you turn the page, we have a couple examples. It's just kind of more of an introductory level of solving an equation for a specific variable. It's called a literal equation. What this means is you may have more than one letter in the problem. And if it says solve for y, so for example, on 21, it says solve for y and you have x and y, you're not going to get a specific value for that letter. You're going to get an expression. So basically you're moving it around. And I like to say really what we're doing is we're going to isolate our y. So since this is the term that doesn't have a y, we want to move it to the other side. Okay, so think of it like any other equation, but we're just applying those rules to get that y by itself. So since that's a positive 8x, I would subtract 8x on the other side of this equation. So don't forget to pick that negative up in front of that y. So I have a negative y. Now, In the past, hopefully you had kind of learned about descending order a lot of times, or basically you really do want to put your term that has a variable before your constant. It would be okay if you wrote 5 minus 8x when you brought this down, but I like to put my term with the letter first, just because I'm in the habit of doing that from writing it in descending order, and then bring down your positive 5. Okay, so we don't want to know what negative y equals. We want to know what positive y equals. So what we do is we divide everything by a -1. And that changes all the signs to just the opposite. Basically, we just kind of manipulated it to fix that. So they all become the opposite. So this would be a positive 8x, and that would be a -5. So think of those sign rules. And then finally, if we're solving for z, we have z's and y's. We're going to move the term that doesn't have a z to the other side first. So since that's a -3y, I would add 3y first to move it over, because I want to zero out that entire term. So 4z, and then I would just bring down my equal sign. I know it's a little bit to the left if it's not exactly straight down, but that's okay. We zeroed out our y term. And again, since this is an 8 and a plus 3y, you could bring that down, but I like to write a positive 3y first. And since that's a positive 8, we could write plus 8. We're not writing the sign that's always just between them, that it looks like here, like 8 plus 3y. I didn't write plus there just because I had 8 plus 3y. I wrote plus 8 because it was a positive 8. Over here, I had to bring down my -8x with it. So again, I'm just trying to really emphasize those sign things, because sometimes those are little things that are messing up and making us get the wrong answer. So to get z by itself, we need to divide each and every term by that 4, kind of like when we divided by a -1 over here. So we have 3 over 4y plus 4 goes into 8 2 times. So we get an expression for z. I don't really know the value. I'd have to know the value of y to find the real value of z.